At the end of last class, we finished taking a look at this high-level volume structure for the exFAT file system. This gives us a pretty big idea of where major structures are in this file system. So really quick overview of this again. The one important part that we really need to know about is this main boot sector structure. This is where there's metadata about the file system, including things like where we can find the other structures that we really want to know about in the volume itself, in terms of things like offsets and stuff. So the main boot sector will tell us things like what's the location of the FAT, this structure here that we really need to be able to build up cluster chains. So when we're trying to reconstruct data or get information about directories out of this file system, how do we find all those locations? The other thing it tells us is where is the cluster heap? So relative to the start of the volume in sectors, where can I find the start of the cluster heap structure here? It also has other important information like how big clusters are, and it measures this in sectors and how big sectors are, and this is measured in bytes. There's a lot of other stuff in this file system, so like extended boot sectors, OEM params, boot checksum, duplicate of the MBR itself, but all of this stuff is stuff we don't really super care about. A lot of this comes from table 3 in the exFAT documentation, and I've kind of taken that table and flipped it on its side so it looks a little bit more like an array, which is something that at least works naturally for me. The main boot sector itself is documented in table 4, and one of the properties that we can make assumptions about with this main boot sector is, regardless of what the main boot sector itself says is the size of a sector, the main boot sector structure will always be 512 bytes in size, and it's always going to start at the very beginning of the file. Where we wanted to go to in class yesterday, so this is in lecture 4, was to finish building up this worked example of finding files and directories in an exFAT formatted volume. We're focusing here mainly on the FAT and the cluster heap, and what we had finished doing last class was building a cluster chain for the root directory itself. So we have some important information about this volume that we're working with from the main boot sector, and the first one is that we're going to have to find out what the first cluster of the root directory is from the main boot sector. And in this contrived example, it's 2. But in many cases, it's going to be a much larger number or something that doesn't look exactly the same as 2. The other thing that I'm contriving in this example is that we have a fixed cluster size at 128 bytes. The size of clusters, remember, is going to be some multiple of the sector size. So this is not realistic. This is just a contrived example just to fit things into a diagram. But what that tells us is that we know how many bytes are in the cluster, and we're going to be able to use that to help figure out how many of other kinds of structures there are going to be in this. So what we had done before with the FAT was we started to build this cluster chain for C. These cluster chains are linked lists, and we're building this from the FAT by looking at entries in the FAT. So the first cluster, the root directory here, is marked as 2. So we add 2 as the first node to this list, and then we look at entry 2 in the FAT itself. The value here is 3, so we add that to our list, and we go to location 3 in the FAT. The entry here is FFFF, and what this says is that this is the end of the cluster chain, so there's no more nodes to add to this. So we add null to the end of our list. In practice, when I'm doing this, like getting data out of the file system, the exFAT file system, I'm not actually building these cluster chains. I'm only going back to the FAT and finding out what the next cluster is in the chain when I need to do that. So I don't actually build a linked list structure for these things, but it's easy to conceptualize this as a linked list structure. The thing that we're going to find in the root directory's first cluster, so once we know what the first cluster of the root directory is, we can go to the beginning of the cluster heap. And remember that unfortunately, the first cluster in the cluster heap is cluster number 2. So this here is the 0th entry in the cluster heap. If I were to seek to the cluster heap offset using the information from the main boot sector and multiplying it by the correct value, because that's going to be measured in sectors, this one is the very first one that I'm actually going to find in the cluster heap. There are no clusters 0 and 1 here. So we're going to the first cluster, the root directory, and we know that this is a directory, and what we're going to find in the clusters for the root directory are information and metadata about the files that are in the root directory. And there are two files in the root directory. There's hello.txt, which is a regular file, and there's directory, which is a folder. It's a directory. When we're looking at the clusters, we're looking at the cluster for a directory, they are always going to be filled with this structure that's called a directory entry. There are many different kinds of directory entries, but in terms of the ones that represent the actual files, the ones that we care about are one that's called the file directory entry, one that's called the stream extension directory entry, and one that's called the file name directory entry. Every file that's in a directory is going to have exactly one file directory entry, and this is the first one that represents the file. It will have exactly one stream extension directory entry, and it will have at least one file name directory entry. These three things, or these n things, so file, stream extension, and however many file names there are collectively called the entry set for a file. So hello.txt here is going to have a file directory entry, a stream extension directory entry, and at least one file name directory entry. Each of these structures, every kind of directory entry, so not limited to just these three, but every kind of directory entry that there is a 32-byte structure. The first byte of the directory entry will tell us what kind it is, and then the information that follows is going to be how we interpret the remainder of those bytes. So when I look at the first cluster of the root directory, what I'm going to find is in practice, there are many directory entries that will appear before the entry sets for the files, but we're glossing over that for this example. So we're going to pretend that the very first thing that I find in this cluster is the file directory entry. This file directory entry is the first directory entry for the entry set for hello.txt. The file directory entry has a bunch of metadata, and the one that we mainly care about right now is the type. So this part of the file directory entry will tell us whether or not this thing is a file or a folder. In cluster 2, the file directory entry here is telling us that hello.txt is a regular file, so this is not a directory. The next physical thing in this cluster is the stream extension that is the part of the entry set for hello.txt. The stream extension has a few different pieces of information that's important to us. The first is the first cluster for that file or folder. This is where we are going to go next if we want to get the data for that thing. The other thing that it tells us is how many characters are in the file name for this thing, and it will also tell us how many bytes are in the file itself, so how long the file is. The length of the file name is something that we're going to need to know to be able to calculate how many file name directory entries there are going to be for this file in this entry set. There are always going to be exactly one file directory entry. There's always going to be exactly one stream extension directory entry in an entry set for a file, but there's at least one file name directory entry. Each file name directory entry will have up to 15 characters of the file name, and in exFAT, the maximum file name length is 255 characters. So that means that there could be many file name directory entries right next to each other. In the contrived example that we're looking at here, hello.txt has 1, 2, 3, 4, 5, 6, 7, 8, 9 characters in its file name, so it will have exactly one file name directory entry. So the actual name of the file will be in this next spot here after that stream extension, And now this here is a complete entry set for hello.txt in the root directory. If I wanted to open hello.txt from the root directory, I'm going to have to start at the main boot sector to find the first cluster of the root directory. I can completely skip over the FAT for now because I don't really need to know where the next cluster is yet. I'm only going to start working in the current cluster. And I'm going to start scanning through these directory entries to build up an entry set and find the entry set that has the file name that's equal to hello.txt. In this case, conveniently for us, it's the first entry set that we have here. So I'm going to then use the stream extension for this entry set to find the actual data for hello.txt. And this says that it starts at cluster 4. In cluster 4, the very first byte, the 0th thing that we'd find in this is going to be the H, the ASCII character H, the ASCII character I, and then the ASCII character for the new line symbol, or the next line symbol. The stream extension will tell us that there's only 3 bytes in this file, so we don't really have to worry about going back to the FAT to build a cluster chain for this because the size of the file is less than one cluster. If I wanted to open up directory, so if I wanted to scan the contents of the directory that's called directory that's in the root directory, then what I'm going to need to do is go to the main boot sector and find the first cluster of the root directory. Then I'm going to start scanning through the entry sets that are in this folder until I find the entry that has a file that indicates that this is a directory because we're trying to open a directory here, and 2, a file name directory entry that matches directory. So in this case, I'm going to skip this entry set because it's not actually a directory, so it's not matching the thing that I'm looking for. At this point, I'm at the bottom of the cluster, the first cluster of the root directory, but I haven't yet completely built up an entry set for this thing, directory. So once I'm here, I will have read this last directory entry, and now I'm going to have to go back to the FAT to find out what the next cluster is in the cluster chain for the root directory. So go back to the FAT, find entry 2, and see that it's number 3. Then I can go back to the cluster heap and go to cluster number 3. Keeping in mind we have to do that absurd off by 2 arithmetic once we get to the cluster heap itself. Then we can keep building up the entry set for the directory that we're trying to find. So we know that it's a directory from the first thing that we read. We now know that the stream extension has a first cluster of 5. Then the length of the name here is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 symbols or 9 characters in the word directory. So there's going to be exactly 1 file name directory entry. The file name here is going to say directory. And so what we're going to then say is, yeah, hooray, yes, thumbs up. We found the thing that we're looking for. And the first cluster for that is cluster number 5. We're trying to open a directory, so when we go to cluster number 5 here, we know that these are now more directory entries here. If we were looking for something else, so we were looking for a directory that's called, I don't know, Walter. That's the name of my cat. Yeah, I'm looking for Walter, the folder named Walter. If I were to scan through all the directory entries here for the entry sets for the files and folders that are in the root directory, eventually I'm going to have to skip past them all because there's no file that's named Walter in this directory, and there's no directory that's named Walter in this directory. So directory entries then that have an entry type here of 0x00 have a special meaning that says this is the end of the directory. So there's nothing else after this, and you should stop trying to find more directory entries here. One last example here is if I'm trying to open up this file, image.jpg. Image.jpg is going to be something that's quite a lot bigger than what we had with hi.txt. This is something that we'll contrive as being much bigger than one cluster. So the approach to find image.jpg is, as before, we're going to start at the root directory, the first cluster of the root directory. We're going to go to the cluster heap. We're going to start scanning through the directory entries here. And the thing that we're trying to find here is I'm trying to open up c:\directory image.jpg. So I have to go to the root directory, scan the contents of the root directory for a folder that's named directory. So I'm going to have to tokenize this stuff a little bit. I'm going to find this entry set that is for the file that doesn't have, it's not a directory, so I can skip it. I'm going to get to the end of the cluster. I'm going to have to go back to the FAT to find out what the next cluster in this chain is so that it can continue to build the entry set for the thing that starts with file. And here I'm going to say, okay, yes, this matches the name directory based on the value that's in the file name here. So I follow that stream extension, the first cluster in the stream extension, to cluster number 5, and I'm trying to open up image.jpg, which is a regular file. Now I'm going to build up an entry set for the first thing, or the first entry set here, and I'm ultimately going to find that the file name here, which is for hi.txt, does not match image.jpg, and so I'm going to skip that, and then I'm going to go to the next entry set, and the same deal happens here. I'm going to read this first directory entry for the entry set for image.jpg. I'm going to find that this is at the end of this cluster, and so I'm going to have to go back to my FAT to find out what the next cluster in the chain is for directory, and that's cluster number 6. And I can go back to the cluster heap and finish building up the entry set for this entry for this file that's called image.jpg, and I will find that that indeed matches the file name that I'm looking for. Once I found that, then I can say, okay, the stream extension tells me that this starts at cluster 8. So once I go to cluster 8 over here, now I'm going to start finding the contents of image.jpg itself. If I'm being asked to read the contents of this file, I'm going to be asking, so let's say that I'm calling the NQP read, or I'm being asked to read 128 bytes at a time from this file. What I'm going to start doing is reading 128 bytes, so the entirety of this cluster. And then as I'm being asked to read more, I'm going to have to keep track of where I am in this file, so what my current offset is. Once I've gotten to the end of this cluster, I'll go back to the FAT and find out what the next cluster in the chain is. In this case, it happens to be number 9, so I'll go back to the cluster heap and continue reading data from here. One thing that we're contriving here, again, is that in this example, we have cluster chains for everything. I'll mention this in class on Monday, but in practice, there are some places where we're not going to have a cluster chain. There's a special field that's in I believe it's the file directory entry, that is this field that's called no fat chain. And what that says is something that looks actually like what we have here. There's just a bunch of clusters that are allocated, they're right next to each other. So you don't have to build a cluster chain for that. You can just read in contiguous clusters up to the length of the file itself. This takes us through the directory entry types. It takes us through opening up files and looking for files within the root directory, and it takes us through looking for files within other directories or subdirectories. This also gives us some idea of how to work with the FAT and the cluster heap together. The main thing, again, to keep in mind is that the FAT itself is not a 2 offset. This is a 0-based array. The cluster heap itself is a 2-based array. Cluster 0 and cluster 1 do not exist. The very first thing when you scan to the start of the cluster heap, so you go to the cluster heap offset, the very first thing there is cluster number 2. So as you're calculating your way into getting to different clusters, you'll have to make sure that you're doing this off by 2 arithmetic.